Вы выделили шум?
Нет, я просто сказал, когда будет уже громко, тогда не надо говорить. Сейчас же нет трека почти.
Говорите, пожалуйста.
Если вы слышите, что поезд идет громко, тогда не нужно перекрикивать его, потому что...
Ясно. Значит, after Cartesian geometry, we must to live with coordinate systems and solve one of such general problems, straight problems. Is given equation to found geometrical object which related with this equation, which corresponds this equation, yes? And inverse problem. Geometrical object is given. It is necessary to write equation which corresponds this geometrical object. For example, if we consider one-dimensional space, and equation in that case is equation with one argument, then geometrical object is point or system points, the row of functions omega x. This is simple problems, but not always. If we consider two-dimensional space, equation is such kind. Usually try to solve this equation according to y or x, and we have well-known problem which consider in mathematical analysis how to build the graph such functions. There is good arsenal of means for solving such problems. We found intervals of increasing, decreasing, convex, asymptotes, so on. If we in 3D we have such problems, and one always try to solve, to introduce this problem for that problem. We take, for example, z constant and have problem for two-dimensional space. Then y constant and method of sections, we at last receive image geometrical object, for example, ellipsoid. So, straight problem we shall consider well good developed, and I shall not touch this problem. Main attention shall give inverse problem of analytical geometry. In that case, given a geometrical object, for simplicity we shall consider two-dimensional space for simplicity. So sometimes go to one-dimensional or three-dimensional. Meanwhile, in one-dimensional such equation we can consider as two-dimensional. So this is function, so on. Geometrical object is given, we must to write equation. But we must to put this problem more in more detail, more correct. What is it geometrical objects? For example, set of points which belong to the circle and have coordinates, both coordinates rational. I could not draw this object. We consider only those points of that object, both coordinates rational numbers. Such object we can use in applied mathematics, in mechanics. So we must consider this object as some kind of mathematical or geometrical monster. One of the monsters. Another example, more important. Counter set. We also cannot use this set in mechanics, applied mathematics, and others. Sierpinski carpet. There are a lot of such kind of geometrical objects. We must some way, when we will solve such problem, some way eliminate these monstrous objects. But there are other objects, for example, square, this table, the face of this table, or table in, as domain, or this table with inside points. The objects we shall call drawings. Objects which we can meet in reality in our applied mathematics, mechanics, so on. So we eliminate these objects now in terminology, but we must eliminate them in mathematics, in formulas. Then let us, as example, sample for imitation, take circumference. This is geometrical object, gamma. And the inverse problem has For example, such from definition after elimination radical. Such equation. This is the equations which solve this inverse problem for circumference. So, first conclusion is that inverse problem is not has not unique solution, and further we shall try to find such kind formula which can contain arbitrary from one wide functional space functions phi, such function which when, for example, this is omega, when omega is 0 is equal to 0. Such sets of formulas, such kind of sets of formulas, such formulas, we shall call bunch of functions which satisfy condition, that condition. If you don't mind, I use the term bunch. In Russian, pучок. Bundle and bunch. I have dictionary. I took it from dictionary. If you want, bundle, это when I use tie, then I make bunch. But this problem we shall consider later when we begin to solve boundary value problems. Now we shall continue our construction. Suppose here is square root. Then it is easy to see that this left part of the equation is not definite everywhere on the plane. If I take point outside of circle, then here is not a definite conclusion in real. So, first request to functions when we solve inverse problem, first request, this function must be such kind. And of course, it is natural request functions must be continuous. But if omega is continuous functions, then equation define defines closed L. So, using continuous functions, we must, when we make statement inverse problem, we must take only closed sets of points. Drawing given must be closed. That way we eliminate such kind of monsters, because such set of points is not closed. But contours, Sierpinski's carpet, are closed. So, if equation is continuous, then geometrical object is closed. But inverse, if L is closed, then equation exists, continuous equation, such objects. For example, infimum this equation is satisfying on points of object L. If x and y are on L, then infimum is 0. And this is continuous functions. It is easy to prove. So, for any closed sets exist continuous functions. So, for counter space, for carpet Sierpinski exists continuous equation. Now, I want to write one example which is in the textbook academician Alexandrov PS. His thick book, Analytical Geometry, there is such example in today. Here, consider such equations in today. And it is easy to see that that is not equation of the line, but this equation of half of the plane. And this is some look like unnatural, because we often meet in books such phrases. Let us given the line, or let us given the surface. very often we can meet such, but in that case, what we must to think about this example. Alexandrov write that such phenomena explain that this equation is only continuous, only continuous function. Then he say, if we shall take more narrow sets of functions, then we shall receive more narrow sets of geometrical objects. And at last, somewhere, we meet such situation when this phenomenon will be eliminated. When you, for example, set of elementary functions, polynomials, but where in such point of this line is jumping from such kind of objects to line or surface in two-dimensional space lines. There is such theorem of Whitney, H. Whitney. If for any geometrical object we can write continuous equation, then for this object we can write infinitely continuous equation. How to understand such phenomenon? Sets of functions is narrower and narrower, and of course we can hope that narrower will be such of geometrical objects, but because theorem Whitney, this not happen. It is easy to understand. For example, let us consider Alexandrov sample. Suppose I consider this equation as function, one argument, and then we have such graphic for the left side. In two-dimensional space, we have such plane and such plane. If I add O here, this surface was not depend on the y, and we shall have such plane and such plane. This is graph such function O. But suppose I change this equation in such way then we 0 left 0, and here we shall have such parabola. In more high degree, it will be more parabola, so on. And we see that we can smoothness do in that point any high order. This is sense of theorem Whitney. I show you this theorem on simplest example. But if we could not find the solution on that part of the line, this line, then we must to consider this more known, well-known sets, polynomials and elementary functions. Let us.
What is it you find objectionable about the Alexandrov example? It is because the set is not locally one-dimensional? Is that the objection?
Not. Here consider it on two-dimensional. This equation on consider in two-dimensional space.
Yes, I understand that. My question is, what do you find objectionable? Why are you unhappy about this example?
I can show you more complex examples. Мне нравится.
Well, then, I don't understand. You say this is only continuous, so we get this set. And if we make it more continuous, we still get only this set. So what is wrong with that set? Why is that a bad example?
I can't understand explanation Alexandrov. She say that this is happen only because this equation is only continuous. More complex example, for example, such equation. This is equation, such drawing. Two line bisectrices and point. We see that this geometrical object have parts different dimensions. 2, 1, and 0. And this is a drawing which can, such kind of drawings we can meet in our practice. We can meet, for example, I meet such kind of drawings. Here is charge, here is virus, yes, here is electrode. Such kind of objects can be met in our applied mathematics. Let us consider what from other end of that line. Let us take out the algebraic polynomials. We knew that polynomials can be constructed due to such kind of system. Using such system, we can construct a polynomial any number of arguments. The set of all such polynomials we have been denoted set of H are realizable functions. Such kind we consider pair weeks ago. For that set of functions, we can consider drawings. Set of drawings which correspond set of polynomials are algebraic drawings. Algebraic lines on plane, algebraic surfaces in 3D case, and algebraic hypersurfaces in n-D drawings. All equations which we consider in analytical geometry belong this Lemniscat, Quadraki, so on. Now, let us consider drawings which can be also based on this system, but pieces of algebraic drawings. For example, if we have algebraic drawings and domain then we part of the algebraic drawing which is the domain shall call, for example, piece of the algebraic drawings. So this piece, for example, L sub 1, can be define such system. This is a piece of algebraic drawings. For example, if I took this plane and, for example, cylinder, then I can receive disk. But if I take sinusoid and part which parted along sinusoid, it was not piece of the algebraic because the domain which we use is not algebraic. So piece mean not any piece, but only those pieces which we can use for dividing, which we can use from set of functions belonging algebraic. And now half algebraic drawings. Semi, yes, semi. semi-algebraic drawings. This is such kind drawings, where those are pieces of algebraic drawings. For example, if I consider square, this is semi-algebraic drawings, because I can take this piece, for example, using circle, this, and union is semi-algebraic drawings. Set of all semi-algebraic drawings, let us denote this set, like this set is fully defined by the system. All properties of algebraic drawings depend on properties of this operation. Origin properties of quadratic, so on, are here in hiding properties of this operation. This also dependent properties, this, but here we must add the properties of Boolean operation. So, such situation now. But of course we see that set is more than algebraic set of algebraic drawings. But maybe they are the same. So we must to show that there is some semi-algebraic drawings which is not algebraic drawings, and then we such drawings which is not algebraic is square. For example, suppose there is some polynomial that this equation is equation of square. Then if I consider that side of the, we shall such kind of equation, and in that case we have not n but continuous roots of this equation. That means that all coefficients are 0. But in that case, this will be equation all z x. So on, we can prove that this is not equation of the square, but equation another drawing. We prove that exactly such dependence. But now we see that S square and other such kind of objects are useful in practice. So that set is not enough for solving inverse problem of analytical geometry. And we shall try now to add something here. Some functions. For example, some elementary functions at here. And shall try to take choose such functions that if we shall consider like here to receive equality. So suppose here suppose this is all set of functions which we can construct it using these functions. This is drawings which correspond to this set of functions. And in the same way, like we constructed set of semi-algebraic drawings, we shall construct it such kind realizable drawings. So these drawings can be received as union pieces, but pieces, these drawings will be another than. For example, if here is sinus among these functions, then we can, using sinusoid, cut part of the plane. It is semi-H realizable set. And suppose I want to such equality. Maybe exist such functions that if we add them here to that functions, we receive such. In that case, if such system H exists, we can then construct it any objects from pieces of this kind of object. This is more rich set than algebraic because we add some functions. In that case, if such, we shall write equations, very complex objects. But does exist this such kind of systems? Let me see that if such set contain any sufficiently closed sets of our functions, then this equality is true. For example, if I so if I add here we shall have here equality, because minus x we can receive using minus 1 multiply here. Disjunctions we can receive using De Morgan rule. we shall see that such kind of systems are complete in sense of completeness, tools of an algorithmic completeness, tools of analytical geometry. In analytical geometry, such kind of systems are from point of algorithmic completeness is good systems. Now, go to examples. Because I see using here such conversation, it is easy to sleep. Now let us consider example. Suppose some domain can be received from simplest domain where f capital is Boolean functions. These simplest domains, suppose, are given by inequalities, where, for example, elementary functions. We also can write that this is this as C S sub 2 I maybe this is such kind Boolean psi of t if and 0 if t less than 0. This operator we use when I give you definition of R functions. This is Boolean variables. One if inequality is satisfied, or 0 if another inequality. Suppose this Boolean functions is accompanying such R functions. Then, by definition, R functions Boolean size of R functions is Boolean functions size of and that means this is sigma capital. So these functions will be positive when omega is unit and negative in opposite sense, opposite case. For example, consider square. This square we can consider like intersections to strips. Vertical strips and horizontal strips. Sigma 1, we can give inequalities. Sigma 2, in that case, our functions we can take, for example, simplest, because omega is this is functions, this is our functions, for which this Boolean functions is accompanying. In that case, we can write equation this is sigma 1, this is sigma 2, and if we shall consider inside the square it will be more than, outside it will be less than 0. But this function is continuous functions. So on the boundary we shall receive 0. Equation square. This symbol we can eliminate if you want, and we receive. You remember this operation. This is equation of the square. Just from that equation, I begin to think about functions which later were called R functions. This name R functions gave them not I, but my sister in Kiev. I live in the time in very deep province, Berdiansk in Ukraine, little town, and received some such kind of results. I sent in capital of Ukraine, Kiev, to my sister, this my note, and asked her, maybe it is good for publishing, for issue. She rewrite that in your own sense, sign instead of me, and go to academician Dorodnitsyn. He give good for our academician journal, and I only see our functions when this receive reprint from this paper, and I say my sister, why you write our letter? It will shame me to say about these functions, but we answer me. You are very high think about yourself. This name I shall done due to our Father, but not you. We miss our Father in 30s. So don't think that I'm such man who write this letter. Now let us consider. We have time, yes? Are you tired? Yes. Let us consider one more example. Suppose drawing is such kind. This is sinusoid. Here is circumference. Such domain. Let us take simplest domains for constructing the domain given. Sigma 1. Above the sinusoid domain. Inside of circumference, the circle. Strip, vertical strip, and above that line. Then for omega, we can write the formula. Sigma 3 vertical and sigma 2, it will be stripped with such domain. Then 2. Then sigma 1 above sinusoid and if sigma 4, what's such kind formula? Above sinusoid and this domain very simple. Then when we shall use rule which I explained, this one of the main theorem of our function theory, we can write instead of these symbols left parts of this inequalities. Sigma 2. That side, then, and sigma 1. This formula, denoted it by symbol omega, this formula is positive inside omega, negative outside, and due to continuity of this formula, the rho is on the boundary. So if I consider such family